STARAMAKI, we are dedicated to innovating sustainable agricultural manufacturing, and this project has been a fantastic opportunity for us to advance our mission. STARAMAKI's core product, the drinking straw made from wheat stems, embodies the principles of sustainability, circular economy, and social responsibility. To overcome the typical manufacturing difficulties associated with bio and nature-based solutions, STARAMAKI recognized the need for an agile and automated facility.
What we're doing with the STARiot project is to actually make it much easier for the people working at the staramaki factory to collect the data that they're collecting right now through online forms or sometimes even through papers. So this data that we collect is much richer than what we're collecting before. And using this data, they can gain a lot of insights, what they actually can improve in the factory.
We need to know exactly the amount of available raw material, its origin and age. With CommonsLab, we built a solution that accurately and effortlessly tracks the flow of materials throughout the production.
We have this nice little handheld IoT device which uses GPS, geotagging, it uses NFC communication technology, and this can be integrated in the workflow that they already have. They can just tag the system, scan the data that they want to scan, and fortunately this way they don't have to stop what they're doing. They can just beep the thing, continue with what they're doing, and that way they can actually flow the products through the processes much faster. All the data that they collect this way finally gets aggregated in a server online, and the ramp dashboard that is provided by the Better Factory then visualizes all this data in the most easy to understand way. The data can also be used later to communicate to the customers that they already have or that they want to gain about the ethical way that they actually work in the staramaki factory. So they can back this up with good data, and the investors that they try to attract as well, they can show them that this is the most efficient way that they're running this factory, or at least they know how to run this factory in the most efficient way.
The upgrades increase throughput, improve safety, and avoid human error. In the long run, we can lower the production cost and achieve better efficiency, and this also improves the well-being of the staff.
So we hope that this tool that we developed is going to be able to contribute and build a more sustainable manufacturing system all around it. In the end, we hope that the STARiot project will be able to contribute to the manufacturing sector a tool that will make it easy and possible to produce more sustainable products in the future.
Project STARiot brought together a diverse team that developed new ways to upgrade our factory operations and produce new items, especially from disqualified drinking straws. STARAMAKI and the artist Gilbert Sinnott worked together to repurpose disqualified wheat straws and other natural materials into educational and artistic products. And by broadening our range of sustainable products, we can tap into markets and get new revenue streams.
We've been exploring polyhedra, which are a type of geometric three-dimensional shape with historical significance in Greek mathematics. These concepts have been developed into an educational product which uses disqualified drinking straws from the manufacturing process to create educational construction kits. For this, I developed interactive tools that allow us to communicate and explore the properties and geometric relations of polyhedra and show the orthographic symmetries between them. For staramaki, they can use this to explore different shape designs and generate step-by-step instructions. And for the customer, it allows them to interactively and visually engage with the product. We've also explored other regenerative natural materials and methods, and this is arundodonyx, which is a type of giant reed similar to bamboo that can be found widely in Greece. Plugs and connectors have been designed that can join reeds into polyhedra. They adapt to the natural variance of the reed diameter, approximately 1 to 2 centimeters, and they are made with recycled and compostable filaments. We have also looked into tensegrity and tensegrity polyhedra. This is where string or cord can be used. and the compressive and tensile forces in the polyhedra are balanced to create a solid shape. By providing end-to-end educational resources, we can support hands-on creativity, learning and sustainability.
So we hope that this tool that we developed is going to be able to contribute and build a more sustainable manufacturing system all around it. In the end, we hope that the STARioT project will be able to contribute to the manufacturing sector a tool that will make it easy and possible to produce more sustainable products in the future.
What we gained from Better Factory was a streamlined production process and valuable insights into the potential of advanced technologies to improve our overall operations. We have enhanced our production capabilities, but also found new ways to engage the community and promote sustainable practices. Our goal is to solidify our position in sustainable manufacturing and inspire other industries to adopt more conscious and socially responsible practices, contributing to a more resilient future for the manufacturing sector as a whole.